Welcome to Activity 2, a little heat from me to you. So again, our learning target is we're going to determine if thermal energy can be transferred from one object to another. Now, you're watching a video of this lab, so it should go pretty easy. You don't necessarily have to worry about safety. But what I have set up here is I have a Bunsen burner, and I'm going to light the Bunsen burner. And it's going to heat the bar. Now, what I want you to do is first, I want you to make a prediction. Which shortening ball will fall from the rod first? Will it be the first one? Will it be the second, third, or fourth? Or do you think they're all going to fall at the same time? So if you have your Chromebook, open up Activity 2 and go ahead and make the prediction. If you have the paper copy, go ahead and circle which one you think it is. Number 1, number 2, number 3, number 4. And then why do you think that? So go ahead, pause the video, make your prediction, and type up or write up why you think that. All right, so now you've had a chance to do that. What I'm going to do is I'm going to light the Bunsen burner, and I'm going to start my stopwatch, and we're going to start filling out the data. I will call off the fall time, and you're going to be able to see what time it is. So I'm going to call off the fall time. Make sure you record this on your lab. Then you're going to be able to calculate the time difference. Once you get done with that, you can finish up the making sense questions, number 1, number 2, number 3, and number 4. And number 5, go back to the conduction and convection handout and modify our model if you think anything needs to be modified. So I'm going to go ahead and I'm going to get a match lit. First, though, I got to turn our gas on. All right, so I'm going to light another match, and now it should light a lot easier once I've turned the gas on to the classroom. I'm going to adjust the flame a little bit. I've started the stopwatch, so I'm taping it, starting it. So I'll call off the times when the first one falls. Now I'm going to turn this a little bit. It's getting a little too much oxygen. So the timer's running. And we're just going to wait and see when the first one falls. So what I did was I had 3 inches between here and there, and then I had 1 inch between each of the other pieces of shortening. I have some paper towels underneath it, so when the shortening falls, it's not going to get the lab table all messy, and it'll be a really easy cleanup. Again, I'm just timing, and we're waiting to see when that first piece of shortening falls. So we can see it's starting to move. So it's at the bottom. So I'm going to say the first piece of shortening, even though it's technically on there yet, I'm going to say it fell at 2 minutes and 11 seconds. So go ahead and record that for the fall time for shortening drop number 1, 2:11. Every once in a while, the shortening will just go around to the other side, and it'll sit there, and it takes a long time to fall. But yet, you definitely saw that it moved to the other side. So if the other ones do that, we'll use that same data. As long as we're consistent, we're fine. So the fall time for shortening drop 1 was 2 minutes and 11 seconds. Now we're going to wait for shortening ball 2. Each of these pieces of shortening is about pea size, and I wanted to make them about the same size because I wanted them to be a constant. So if I would make one really small, one really large, then it wouldn't be equal. It's hard to tell, but it looks like that second one is starting to slide a little bit, or it's melting. I can see the bottom of it. It's probably a little bit easier for me to see than with the camera. Oh, so we're going to call that at 3:52. 3:52. So the second one fell at 3:52. So record that for the fall time for shortening drop 2. Now, while you're waiting for the next one, you can actually calculate the time difference. Now, the time difference for the first shortening ball is pretty easy. Because we started the timer at 0, it'll be whatever the first fall time was minus 0. Now, to find the time difference for the second one, it's the fall time of number 2 minus the fall time of number 1. So now we're waiting for the third shortening ball to drop. So it looks like it's starting to melt a little around the base. It's probably a little bit, again, it's probably a little bit easier for me to see it because I'm a little bit closer than the camera. So while we're waiting for this fall time, just a reminder that you should finish the making sense questions. And the making sense questions are: what patterns did you see with the fall time of the objects? Were they all evenly spaced apart? Were they not evenly spaced apart? And then why did the objects fall like that in the order that they did? Now, did the thermal, so 6:17. So go ahead, record your third shortening drop at 6:17. So looking again at the third making sense question, did the thermal energy from the heat source transfer directly to the objects? Explain. So did the Bunsen burner, did that energy transfer directly to the shortening balls or not? And then explain. And then 4, at the beginning of this activity, you were asked, how does thermal energy get into the atmosphere? Well, if you weren't here in class, you might have not had that background information, but we did talk about that in activity 1. So you should still be able to answer that. And how would you answer that question after doing this activity? So this is where we talked about how the atmosphere is heated. And then when your class is done, go ahead and, your class will return to the class model. So if you're not here in class, you're doing this on your own, just check in with a partner. Make sure that you've added stuff to the model if we added stuff as a class. So we're at 7:24. We're just waiting for this last shortening ball to drop, and then we'll be done with this activity. Looks like it's starting to slide a little bit. Thought it lurched forward. So I can see it dropping any second now. We're at 8 minutes plus. Ah, there it goes. 9:01. So we are done with this lab. Just make sure you calculate the time differences. Make sure you finish up the making sense questions and let your teacher know when you're done and show them your work so that way you have proof that it's done. Thank you.